Hello, I will talk about special relativity. There are three phenomena that occurs when someone is traveling at very high speed, close to the speed of light. The first phenomenon is the increase in mass. The second phenomenon is the length contraction, and the third phenomenon is time dilation. I will start with the increase in mass. Suppose the twin brother who goes on a journey in space weighs 100 kilograms on Earth. So when he will move in the spaceship at a speed of 80% of the speed of light, that is 240,000 kilometers per second, according to the mass increase equation of special relativity, his mass in space will be 167 kilograms, but he will not feel it. If his twin brother has a mass detector, the detector will measure 167 kilograms. That means his mass has increased by 67%. Okay, first of all I will explain the question. M is the mass of the object when he travels at very high speed, close to the speed of light. And m naught is the rest mass, that is to say, the mass of the object when it is not moving. We divided it by the root of 1 minus v squared divided by c squared. So, in our example, the twin brother on Earth, his mass on Earth is 100 kilograms, and he goes to the travel in the space at a speed of 240,000 kilograms per second. 240,000 kilometers per second. So his mass will increase to 167 kilograms. Okay. So if the twin on Earth has a detector of mass, he could weigh his brother, and he could weigh his brother that is traveling on the space in very high speed. So he can measure the weight of his twin brother, and the mass detector will measure the 167 kilograms, because the mass of his twin brother will increase by 67 kilograms. Okay, now I will talk about the second phenomenon of that occurs where someone is traveling at very high speed, and that is the length contraction. shortening of distance. When you measure a distance between two objects that are not in motion relative to each other, if you measured a certain distance, so the distance between them will shrink when one of them moves at a speed very close to the speed of light relative to the other. So I will explain the equation of length contraction. So L is the distance between two objects when one of them is moving towards the other one in very high speed, and the L naught is the distance between that two objects when they are not moving, when they are not in motion relative to each other. So we multiply it by the root of 1 minus v squared divided by c squared. V is the speed of the object, of one of the objects that is moving towards the other objects. So if one of the objects is moving towards the other object in very high speed, there will be a contraction of distance. And in our example, the distance between Earth and the star Epsilon is 10 light years. So 10 light years is the distance between the two objects, Earth and the star Epsilon, when they are not moving relative to each other. You measure the distance between the two stars when they are not in motion relative to each other, and the distance is 10 light years. But when someone is moving from Earth in the spaceship at very high speed towards the star Epsilon, when he is moving in the spaceship at the velocity of 240,000 kilometers per second, so his distance from the spaceship to the star, the distance between the spaceship to the star Epsilon will be shrinked to 6 light years only. Okay? That phenomenon is called the contraction of distance. Okay, so the distance between Earth and the star Epsilon will be contracted from 10 light years to 6 light years only when someone is moving in the spaceship at a speed of 240,000 kilometers per second towards the star Epsilon. So because of the movement at very high speed towards the other object, the distance will be contracted from 10 light years to 6 light years only. Okay, but in addition to that, the height of the man in the spaceship also shrinks. and if on Earth his height is 1.8 meters, then from the point of view of the twin brother who remains on Earth, the height of the twin brother in the spacecraft shrinks to only 1.08 meters. If the twin brother on Earth had a height detector, then the detector would show a height of only 1.08 meters. But the twin brother who is on the spacecraft doesn't feel that he is shorter. So L is the height of the object of the man that is moving at very high speed on the space, and L naught is the height of the twin on Earth. And we multiply it by the root of 1 minus v squared divided by c squared, and so in our example, yes, L naught is 1.8 meters, so 180 centimeters, and when we multiply it by 1 minus 240,000 kilometers per second squared divided by the speed of light squared, we get the height of 1.08 meters. So the height of the man that is on space and traveling at the speed of 240,000 kilometers per second, his height was shrinked from 1.8 meters to 1.08 meters only. So, as I have already said, if his twin brother that is on Earth had a height detector, the detector will measure a height of 1.08 meters. So the brother that is on the spaceship is height shortened by 72 centimeters, from 1.8 meters to 1.08 meters only. Okay. Now I will talk about the third phenomenon that occurs when someone is moving at very high speed. The third phenomenon is time dilation. As mentioned, from the point of view of the brother who is on Earth, his twin brother is moving in the spaceship at a very high speed. Therefore, the rate of time flow in the spaceship will be slower than the rate of time flow on Earth. While on Earth, it took 25 years for the twin brother to return from a journey in space. In the spaceship, the total time it passed is 15 years only. So, I will explain the equation of time dilation. T is the time that is passed on the spaceship when the spaceship is moving at very high speed. The time that is passed during the journey from, for example, from Earth to the star epsilon and from the star epsilon back to Earth, the total time that is passed in the spaceship, and the T naught is the total time that is passed on Earth, and we multiply it by the root of 1 minus v squared divided by c squared. So on Earth, the total time that is passed during the journey is 25 years, and when we multiply it by 1 minus the velocity of the spacecraft, that is 240,000 kilometers per second, divided by the speed of light, we get the 0.8, and when we square it, 1 minus 0.8 squared is actually 0.36, and the root of 0.36 is 0.6, and when we multiply 0.6 by 25, the result is 15 years. So the total time that is passed in the spaceship is 15 years only. So that is the reason that the twin brother that returned from the journey to the star Epsilon will be 10 years younger than his brother that stayed on Earth. Okay. While from the point of view of the twin brother who embarked on a space journey towards the Epsilon star, he is at rest, and the Epsilon star is moving towards him at a speed of 240,000 kilometers per second. Therefore, in this situation, there will be a contraction of distance according to special relativity. And the total distance between the Earth and the star Epsilon will be 6 light years only. And the round trip distance is 12 light years, and at a speed of 80% of the speed of light, the entire journey in a spacecraft will take 15 years due to the contraction of distance between the spaceship and the star Epsilon as mentioned. So from the point of view of the twin brother that is on the spacecraft, he is at rest, and the star Epsilon is moving towards him at the speed of 80% of the speed of light, that is 240,000 kilometers per second. And in this situation, there will be a contraction of distance, and the distance between him and the star Epsilon will be contracted from 10 light years to 6 light years only. So all the trip back and forth from the star Epsilon to Earth will be 12 light years in total, and when we divided it by the speed of the spacecraft, that it's 240,000 kilometers per second, we will get the total time that it traveled in space, that is 15 years. So according from the point of view of the brother that is on the spaceship, he also calculated the total time that it will take him to do all the journeys, only 15 years, 10 years less than the time that is passed, that was passed on Earth, that is 25 years. So that is the reason that you will be 10 years younger than his twin brother that stayed on Earth. Okay, thank you very much.